everyone, we are from Group 4. My name is Livika.
Hi, my name is Siti Nabaya.
Hi, my name is Wano Azmira.
Hi, my name is Nurbat Shamira.
So we have the system that we have developed is AI-based emotion recognition system using Teachable system, which can analyze facial images. Next. So the content includes the first one is introduction and background, second is problem statement, third is objectives and techniques, fourth is framework of the system, fifth one is proposed predictive model or methodology, sixth one is data set preparation and training process, seventh one is demonstration teachable machine, eight is results and discussion, ninth one is conclusion and future work. Next. So as for the introduction and background, first is in terms of emotion in communication. So emotion is central to human interactions. We show feelings like happiness or anger through facial expressions. Effective computing teaches computers to understand these emotions, making AI more natural. Importance of recognition. If machines detect emotions, they can respond better and faster than humans. This improves user experience in apps and devices. Applications. Emotion recognition is used in education, customer service, security, and mental support. It helps detect moods such as happiness or anger to enhance interaction. Last one is project goal. Build a system to classify basic emotions from facial images and display labels automatically. Next. So as for the problem statement, we have first one, we have machines struggle to interpret human facial emotions. Current systems detect only a few basic expressions, missing subtle emotions. This limits effective communication with digital platforms. Need for AI that accurately recognizes emotion to improve interaction in education, customer service, and mental health. Next. So as for the objectives and technique, first one is develop an AI model to recognize facial emotions from images. So the technique used is use facial image datasets for training. The second objective is demonstrate accurate interpretation of human expressions. So the technique used is apply machine learning to classify basic emotions. The third one is integrate emotion detection into communication systems. The technique is automate detection for faster, more accurate results. And the last objective is improve understanding, interaction, and responsiveness between users and digital platforms. So the technique used for this is display emotion labels to enhance user interaction. So as for the framework of the system, next one, I will leave it to Siti Nurbaya.
We will continue to framework of AI machine recognition system. On the right side, you can see the system will operate as a closed loop interaction between the user and the AI engine, which is the teachable machine, as illustrated in the figure 1. So it will capture the live facial expression using the webcam that they get from the user, and then it will go to the dashboard interface to process the frame and act as the system front end. And then the image sample will go to the teachable machine model to analyze the visual features against the pre-trained classes. And then it will go to the real-time feedback by return a probability score and display a visual alert to the user, whether they're happy or angry. So moving to the next one. This is the technical workflow of the predictive model. It have 5-stage pipeline to convert images into emotion label. The first step is pre-processing. It will resize the frame to 2 to 4 times 2 to 4 pixels and normalize the brightness for consistency and better result. And then the next step is feature extraction. It will use the CNN, which is convolutional neural networks, to identify the landmark like how the user mouth curve, and eyebrow position. And then the third step is transfer learning. The machine will compare the live feature against the pre-trained mathematical patterns, which is the sample that we insert into the machine. And then the machine will calculate the probability to assign a confidence percentage to each class as their output, like, for example, happy for 98% accuracy. And then lastly, the machine will generate the final output, which is display the highest scoring emotion level on the dashboard instantly after they calculate the probability. Next. So this is the teachable machine dashboard. It's under the model training and data collection. If you can see, we've got two classes, which is defined as happy and angry as the two target labels. So data set for happy, the total sample is 68 samples and 72 angry for angry samples. So the total of both sample is 140 samples to cover the various angle and lighting. So it will train the sample, the machine will train the sample to optimize the mathematical weight to ensure high speed, real-time detection, and accurate result, to get more accurate result. So next. So this is the proposed predictive model, or we call that as methodology. The goal for this methodology is to capture and clean the raw data for the AI. For example, the machine will use the webcam to collect 140 samples of happy and angry expression that we got from the user. And then the machine will capture the different lighting angles and intensities for each sample, which is the raw data, the image. So the image will process by their size, as we stated before, 2 to 4 times 2 to 4 pixel, and it will normalize to ensure the AI recognize the pattern, not the background noise from the picture. Okay. I'm passing to Nurbatisha Amira to continue the presentation.
For dataset preparation and training process, and this slide will show you the table of the emotion category and training samples and testing confidence. So we have two category of emotion, which is angry and happy. And for the training samples for happy emotion is 68 images and the testing confidence is 100%. For angry emotion, we have 72 images and testing confidence is 97%. So the total image are 140 images and the total for testing confidence is 98.5%. So the model utilized a total of 140 images, achieving a high classification rate during the validation phase. Besides, the utilizing a balanced dataset 68 happy versus 72 angry. The system minimized classification bias, ensuring both emotions were recognized with equal precision. Next, demonstration, teachable machine video. In this slide, we will show you the real-time demonstration video. The video demonstrates the real-time capabilities of the model. The system captures live frames, process them through the CNN engine, and provide instant feedback as the user's expression change from happy to angry. Live video mode, static analysis. This video shows the model's ability to process pre-existing data. By uploading specific images file, the system demonstrates consistent classification accuracy, proving that the predictive logic remains stable regardless of the input source.
So I continue the result and discussion. System performance based on the 140 image dataset. The system achieved on average accuracy of 98.5% by balancing the by balancing the clusters with 68 happy and 72 angry samples. The model eliminated classification bias, resulting in a perfect 100% confidence score for happy expression and 97% for angry expression. Key findings: the AI successfully isolated specific facial landmarks, specifically detecting the upward mouth curvature for happy and eyebrow furrowing for angry. The system processed this visual data with minimal latency, ensuring a responsive, real-time user experience that meets all functional requirements. The conclusion that the conclusion, we achieve 98.5% average accuracy using a balanced 140 image dataset. We successfully mapped facial landmark, which is mouth and eyebrows, to specific emotional states. We also developed a real-time dashboard with low latency and high stability. In future work, we want to add more emotion categories, which is sad and surprise. We also want to create a history log to track emotional data over time. We also want to improve detection in low light and different camera angles. So that's all from us. Thank you.